let's look at solving quadratic equations using factors. Okay, so what does a quadratic equation look like? Well, it can take two forms. It can look like this with three terms, and because it's an equation, the equal sign, and in this case 0. Or it can take the other, and that form actually would be known as x squared plus bx plus c, where a would be the numerical value of the coefficient of x squared, b would be minus 5, and c would be plus 6. Or it can also take a shortened form, as in ax squared plus bx with no plus c at the end. Okay, so there's two forms. We'll meet both of these. And basically, when we're solving quadratic equations using factors, the idea is that we can find values of x that satisfy the equation. Okay, so in other words, if we found that x equal to 1 and we let x equal 1 here and here, then all of that would be equal to 0. Okay, and that would, if that all equates to 0, then x equals 1 would satisfy the equation. Okay. Anyway, so how do we do that? Well, we'll find the factors of the equation and we'll let those factors equal to 0. So for example, if I have an equation like x squared minus 5x plus 6 equals 0, then the factors of that are x and of 6 minus 2 minus 3, signs positive, both the same. What are they? Both negative from the other videos. Chapter 2. So basically x minus 2 and x minus 3 are the factors of that equation. That's all from chapter 2. And so if we let those factors, okay, sorry, before I jump ahead with that, if the equation is equal to 0, then the factors that when multiplied together, they're equal to the equation when they're multiplied together, they must also be equal to 0 too. So we can then say, okay, we'll just take one, x minus 2 is equal to 0. We can let x minus 2 equal 0, so x will be equal to 2, because the 2 will come around here. Or we can also say x minus 3 is equal to 0, and that 3 comes around here. X is equal to 3. And x is equal to 2 and x is equal to 3 are the solutions, roots, or zeros, what they're known as, of the equation. Okay? And, you know, this whole notion of letting them equal to 0, if we say x minus 2 by x minus 3 equals 0, well, if I wanted to find what just x minus 2 is equal to, I divide both sides by x minus 3, and they would cancel, and that's equal to 0. 0, you get your calculator out, 0 divided by 3 is equal to 0. 0 divided by 100 is equal to 0. So x minus 2 is equal to 0, and that's where we got this from, and that as well. Okay, you won't meet with that again, but you will meet with just by letting these factors equal to 0. This is where it comes from and why. Okay, so we're going to solve some quadratic equations in a second, but the how-to guide, I suppose, really is to make sure that this says rearrange, badly written, first thing is you rearrange the equation so that one side is equal to 0. So if you have some terms equal to other terms, then you want to bring those other terms back over the equal sign, so that everything on one side is equal to 0 before you can carry on. You then find the factors of that equation, you let each factor equal 0, and you just find or solve the value for x. Okay. So the first example, we'll get it all into view here. Solve x squared minus 5x minus 14 equals 0. Okay, well the way I'll find the factors is this. I'm looking to make minus 5 out the factors of minus 14. 2 sevens is 14, minus signs has different signs for the factors. X by 2 is plus 2x, x by minus 7 is minus 7x, minus 7x plus 2x is minus 5x, that's what we want. So the factors are x minus 7 and x plus 2. Now x minus 7 equals 0, x equals 7, x plus 2 equals 0, x equals minus 2. If you were to sub x equals 7 or x equals minus 2 back into this equation here, it would all equal to 0. Now here's the second example, but now we're going to find the factors via the highest common factor method, which we learned in chapter 2. So solve 2x squared minus 9x equals 0. So this is in the form ax squared plus bx, as we mentioned at the top of the video. So 2x squared minus 9x equals 0. If we just tease the x out here, the highest common factor of this term and of that term is x, which we did in chapter 2, then and then divide each term by x so 2x squared over x is this term, 9x squared is that. These are the factors of this equation, okay? Because this by this will give this equation. So now we let those equal to 0. So x is equal to 0, and 2x minus 9, this factor here, is equal to 0. Let 2x equal, so therefore, bring that over there, 2x equals 9, x is equal to 4.5. Now we'll find the factors of a quadratic equation. This time we'll use the difference of two squares method, which we met in chapter 2 as well. So let's solve 4x squared minus 25. So here we go. 4x squared minus 25 is equal to 0. The factors of this equation via the difference of two squares is the square root of 4, square root of x is 2x plus 5 multiplied by 2x minus 5, square root of 25 there. So let 2x plus 5 equals 0, 2x equals minus 5, x equals minus 2.5, and or let 2x minus 5 equals 0, 2x equals 5, x equals 5 over 2, x equals 2.5. So it's either to minus 2.5 or 2.5. Either way, plug that in there and it will equal 0. Now, just something worth noting as kind of aside or discussion in the book. It's just so that you know that if you were to graph a quadratic equation, as we've met, you would get, or you would produce a parabola shape, either this or that. Okay, so let's say we had an equation, and we'll say that y is equal to that equation. In other words, if we let x equal minus 3, and wherever we see x in this equation, we'll get an output value for y. Okay, and if we let x equal minus 2 and put it in here and here, we'll get an output value for y, and so on. So if we had a domain of inputs here, we'd get a range of outputs here. If we then put these together as a couple or ordered pair and plotted on the x-axis and the y, minus 3, 4, if we plotted those points and joined them, we'd get our parabola shape. Okay, and what's interesting is that where the parabola cuts the x-axis, this point and this point, cuts this point at x equals minus 2. This point at, remember this is the x-axis and the y, cuts the x-axis here at x equals 1. So x equals 1, x minus 1 is equal to 0, and here x equals minus 2, so x plus 2 is equal to 0. X plus 2, x minus 1 are actually the factors of that equation. So x plus 2 by x minus 1 would give us the original equation, and that's why they're known as the zeros, because they tell us where the graph of a plot of the graph of the equation cuts the x-axis at y equals 0. Now, sometimes we have to use the quadratic formula, because sometimes quadratic equations cannot be factorized so easily as to yield x values that are integers, i.e. whole positive or whole negative numbers. So we have to use the quadratic formula, because we could have x equals 0.34 or x equals minus 2.67 or whatever. Okay, so let's take an equation that we can't factorize, 5x squared, or that we can't get the whole positive and negative numbers as the values of x. Where x is not, the solution x is not equal to an integer. That's what I'm trying to say. So let's take an equation, 5x squared plus 7x minus 3. And underneath that, let's write ax squared plus bx plus c. And then let's box out the 5 and the a. Let's box out the plus b and the plus 7. And let's box out the minus 3 and the plus c. Because we have a formula here that we're going to use, that the solution x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. So we need to know what a is, what b is, and c is, and that's how you find your a, your b, and your c. Write the form underneath ax squared plus bx plus c, and just grab and box the numbers and their signs, the whole term. Okay, so from this equation here, 5x squared plus 7x plus 3, 5x squared plus 7x minus 3, then a is 5, b is 7, and c is minus 3. Okay. So plug all the values in, but be very careful to put it's minus b, so it's always safe to do minus brackets and put whatever b is in here, and we'll tell you why in a minute. Plus or minus b in brackets there times 4, a in there, c in there. Keep your brackets to keep safe, okay? So now minus bracket 7 is minus 7. If you remember, minus brackets 3 equals minus 3. Minus 1 by plus 3, minus by plus is minus, 1 by 3 is 3. Okay, we've done that before. Plus or minus, and this is very, very important here. Where did I get this plus from? I always say to myself, minus by plus gives minus. That minus by minus gives plus. Okay, so you just have to say that to yourself to get the sign right here. So you get minus 7 plus or minus the square root of this added 110. So the important bit is that x is equal to minus 7 plus this value here all over 10, or x is equal to minus 7 minus this value all over 10. So x is either equal to 0.344 or x is equal to minus 1.74. And again, before using the quadratic formula, be very careful and make sure that all the terms of the quadratic equation are on the left-hand side of the equation. So here's another go here. 3x squared minus 6x plus 2. So we box our terms and our signs. Okay, so a is equal to 3, b is equal to minus 6, and I'm doing this on purpose to show you something you need to know. C is equal to 2. So now we fill in, well, we just always write out our equations in the logbook. It's good to just memorize it really, you will eventually. But we write minus, and then in brackets our b value, which is minus 6. So be careful. Plus or minus, minus 6 in brackets, minus 4 by 3 by 2, okay? So now minus by minus 6 gives plus 6. Very important, that sign change. Confuses students a lot. Just be very careful with that. And I haven't done it here because I'm not going to carry on with the sum, but it's just to point that out to you. But to point out again, how do we find the sign of this lump here? Minus 6 squared would be 36. But what's going on here? It's minus by plus gives minus, and that minus by plus gives negative, so it would be minus 36 minus 24. 36 minus 24. Okay, so minus by plus gives minus, and that minus by that plus gives minus. Be careful. Okay. So now let's look at some quad equation type problems from sentences. That says, badly written as usual. Anyway, example 1. The length of a rectangle excluding its breadth by 6 centimeters. If the area of the rectangle, this is in the book, this example. The length of a rectangle exceeds its breadth by 6 centimeters. If the area of the rectangle is 160 centimeters, find its length and its breadth. Okay, so its breadth is x. Okay, and its length is, it exceeds its breadth by 6. It must be x plus 6, okay? And the area is 160 centimeters, okay? So the area is this side multiplied by that side. It's x by x plus 6. So therefore, x squared plus 6x is equal to 160. And be careful then to make sure that you bring all the terms to one side of the equation so they're all equal to 0. So we have x squared plus 6x minus 160 equals 0. Factorize this. The factors are x minus 10 and x plus 16. So x is equal to 10 if we let it equal 0, or x is equal to minus 16. Now that's kind of ridiculous that the length or breadth is minus 16, so we just reject that as wrong. And so we say that the x is 10, and that x is the breadth, so the length must be 10 plus 6 is 16 centimeters.